Okay, today we are talking about solving systems of equations, but with three variables. To solve a system of equations with three unknowns, you need three equations. So this is bigger than what we've seen before. We did this with two equations and two unknowns. If you haven't done that before, you should go learn that before you try to do this. So we have basically a big game plan that I want to tell you first, and then I'll show you how to do it. I'm hoping to fit two examples into my time frame here. But the idea here is we have to combine these equations. With two variables and two equations, we combine them into one equation with one variable. But since we have three equations, when we combine two of these equations, we're going to have an equation with two variables in it. So we need to do that twice. We have to produce two different equations that each have two variables in them. And then we can combine those for one variable with one equation so that we can solve it. In this case, then, we actually need to combine twice. You can use substitution. So I could solve, say, this one for x or this one for z, and then substitute it into the other two. That would produce me my two equations. I don't like doing that because you have to use the distributive property, and you end up having to combine like terms. It's all horizontal and kind of a big mess. If you much prefer that, it will work. I'm going to use elimination because I like the columns. They keep me nice and clean. So looking here, I can eliminate the x's if I multiply, or really the y's, but the z's are going to be easiest because I can use the middle equation to eliminate this 2z and this 2z just by multiplying once by 2. So I'm going to multiply this by 2. I'm also going to letter my equations, equation A, equation B, and equation C, just so I can refer to them later. So if I take B and I multiply it by 2, that's going to give me 4x and 2y minus 2z equals 10. So that's twice b. And I'm going to add that to a, which is 5x plus 3y plus 2z equals 2. And when I add those, I get 9x and 5y. The z's cancel, and I end up with 12 over here. That's one equation with two unknowns, but I need two of those. So the next thing I'm going to do, I already multiplied 2b, and I can use that again, but I'm going to add it to c to produce the other equation I need. 2z equals 10. So c is x plus 4y plus 2z equals 16. So when I add those, I'm going to get 5x and 6y. Those are going to cancel, 0z, and that's 26. Now you see I have the two equations I need. Two equations, two unknowns. If I try to eliminate these, I'm going to have issues because they're not going to cancel right away. So I'm going to make the y's into 30 because that's the least common multiple of 5 and 6. So I'm going to write these equations down below. I'm going to multiply this one by 6, and I'm going to multiply this one by negative 5, which is going to give me 54x and 30y equals 72. And then this will be negative 25x minus 30y equals 130, negative 130. So now when I add these, that's going to be 29x and nothing equals 2 less than 60 is 58, which is very fortunate because that's twice 29. So you can see I used elimination. I combined A and B to make an equation. I combined B and C to make an equation. I combined those two equations to make one I can solve. When you're combining these, you got to make sure you use all three. If you combine A and B twice, then when you try to solve the system you've made, it's all going to cancel out because you didn't use the third equation. Make sure you use all three. So once I have x equals 2, I'm going to go up one step to one of these equations where I have just x and y, because now that I know that x is 2, I can solve one of these for y. So that's 10 and 6y equals 26. In which case 6y equals 16? That can't be right. Oh, x was supposed to be negative 2. So it was negative 10, so this is 36, which means y equals 6. Sorry about that. I dropped a negative sign. So y equals 6. So if x is negative 2 and y equals 6, I can come up here to one of these and solve it. Looking at the coefficients, I think I'm going to use the b here. So I've got 2x, since x is negative 2, that's negative 4. Y is 6, so plus 6 minus z equals 5. And that gives me 2 minus z equals 5. If I subtract 2 from both sides, negative z is 3, which means z is negative 3. 2 minus negative 3 is 5. Yeah, that's right. So negative 2 for x, 6 for y, negative 3 for z. Don't forget to put those alphabetically. So that is the big plan here. We combine two of them, make an equation, combine two, make an equation. Make sure you eliminate the same variable on both of those, because you need these to have the same two variables left over so that you can combine them to have only one variable left over. I'll show you one more example, just real quick. 2x and 4y minus 5z is 18. Negative 3x and 5y plus 2z equals negative 27. And negative 5x and 3y minus z equals negative 17. So we're going to get 3 equations and 3 unknowns, which I can't solve. There's too many, although I will be able to solve it. I can't solve any one of these by itself. I can eliminate the x's, but I'd have to multiply more than I'd like. So I'm going to look at this z down here all by itself. Why do I have just a... Oh, that was supposed to be 2z. I don't know if I said 2z or 27 when I wrote that, but that was supposed to be 2z. So I'm going to use this one because its coefficient is 1, so it'll cancel out easily. C, B, A. So I'm going to cancel out with b. I'm going to take c and multiply it by 2. I'm going to do 2c plus b to cancel out these z's. And then I'm going to need 5c plus a to cancel 5 and a. There's my plan. So 2c is negative 10x plus 6y minus 2z equals negative 34. And b is still negative 3x and 5y and 2z equals negative 27. When I add those, I get negative 13x plus 11y. Those are not nice numbers. 61. Negative 61. Don't like those. They're both prime, which makes it less likely I'll be able to multiply really nicely next step, but we'll find out. So 5c is negative 25x and 15y minus 5z, 5z, equals 5 times negative 17 is negative 50, 35 is negative 85. So a is still 2x and 4y minus 5z equals, oh, you know what I did wrong? I should have multiplied by negative 5. So I'm going to change all these signs. Now when I add, that's 27x. And negative 15 plus 4 is negative 11. Oh, that's very fortunate. I did not see that coming. And 85 is now positive. 85 plus 18 is 90, 103. So I'll just write this one over here. 27x minus 11y equals 103. So those add very nicely. That's 14x. The y's cancel. 42, which is 3 times 14. So x equals 3. Taking a step back, I still got those 11s to deal with. I'm going to go over here. 27 times 3 is 81. Minus 11y equals 103. So when I subtract 81, I get 22. So y is negative 2. And then I'll go up here, smallest numbers. 2x plus 4y minus 5z equals 18. So I'm going to stick in 3 for x, that's 6. Negative 2 for y, that's minus 8. Minus 5z equals 18. So 6 minus 8 is negative 2. I'm going to add that 2 to the other side. I get 5z equals 20. So z is negative 4. So this is 3, negative 2, negative 4. Now here's the advice I have for you when you start doing these, is I went really fast. I do these a lot every year. You don't want to start by going fast. You want to keep your brain on the big picture, going to combine in order to reduce the number of equations and the number of variables, then combine those again. It's a cyclical process, but you want to go really slow because you know I messed up when I was going through and dropped a negative sign, which is death. If you drop a negative sign in the first step, you'll get all the way down here before you even realize something's wrong when the numbers aren't working out nicely. The problems you're going to be doing will work out nicely if you don't make mistakes. So don't rush through these thinking, oh, these take so long, I should rush to get done with them faster. That will just make it take longer. Take your time, double check your signs, and that way you can get it done without making a mistake, and you will thank me. See, looks like this was about 11 and a half minutes, which is good for one of these videos, for me anyway. So that should be what you need to know to get started. When you're doing the homework in class, you can always ask questions.